Number 3, the average density of gasoline is 0.74 grams per cubic centimeter. What will be the mass in grams of 4 liters of gasoline? What is our wanted? What are we after? We want the mass. How many grams? So what's our data? That we got 0.74 grams per cubic centimeter, and then we've got 4.0 liters. So this ratio, let's write as an equivalency. 0.74 grams is equal to 1 cubic centimeter. So that's going to wind up being one of our conversion factors. And the 4 liters is going to be our starting point. And that's a number by itself. It's not a ratio, it's not an equivalency. So let's solve this. We're going to start with our 4 liters. And then we want to use our equivalency to get to where we wind up with grams. So we need grams in the numerator. Cubic centimeters, and liters. Cubic centimeters is a unit of volume, so we're going to be able to use this, but we're going to have to do a little bit more manipulation here. So 1 cubic centimeter is the same as 0.74 grams. So we haven't canceled anything out at the moment. But we need to change those cubic centimeters to, say, maybe milliliters. And that 1 cubic centimeter is the same as 1 milliliter. It's a definition. And so if we did that, cubic centimeters would cancel. We're left with milliliters. And now we can cancel liters, put milliliters in the numerator, liters in the denominator. Milli is the SI prefix, that means 10 to the minus 3. So milliliters divided by milliliters cancels. And then our liters cancels out our liters from the very first part of the problem. We wind up with units of grams, which is what we were after. And so we wind up with 2,960 grams. Makes sense. 3,000 grams for 4 liters of gasoline. 4 liters of gasoline is about a gallon. And so that makes sense. If we'd had 2 million grams, that would have made sense. Or if we'd had 0.002 grams, that would not have made sense. So it's plus or minus a ballpark. So our magnitude of the answer is correct. But now we got to get the right number of significant figures. 2 liters has 2 sig figs. 0.74 grams has 2 sig figs. 1 cubic centimeter per milliliter is the definition. An unlimited number of significant figures. And a milliliter is the same as 10 to the minus 3 liters. That's the definition, or an unlimited number of significant figures. So we're going to have 2 significant figures. So let's round this answer to 3.0 times 10 to the third grams. That's really the only way to reflect the 2 sig figs accurately, is to use scientific notation. So 3.0 times 10 to the third grams. The next one is an English to metric conversion. What are we after? We want to know mass in kilograms. So what's our data? We got 184.6 pounds. So we go to mass to kilograms. So conversion factor that I have is that 1 pound is equal to 453.6 grams. If you know some other conversion factor directly between pounds and kilograms, you can certainly use that. But I'm wanting to use this one to show how we might have to have multiple steps in a problem. So this is going to be my conversion factor, this equivalence, and the 184.6 is going to be my starting point, my given. So 184.6 pounds. A pound is It's the same as 453.6 grams, because I wanted pounds to cancel pounds. They got grams, but it wasn't after grams, it was after kilograms. And so we need a conversion factor between kilograms and grams. Kilo is an SI prefix that means 10 to the third. So now grams cancels, and that gives us kilograms. In fact, it gives us 83.73456 kilograms. 4 sig figs, a definition. So my answer can only go out to 4 sig figs. So 83.73 kilograms. Kilograms is the unit that I wanted. And the answer makes sense. It's not 83,000 kilograms. It's not 0.083 kilograms. It's plus or minus a ballpark. So it ought to be a good answer.